Section 2.1 deals with tangent lines and rates of change. We'll start by discussing slopes of secant lines and average rates of change. Right. In this example, we'll find the slope of the secant line to the graph of f of x equals x cubed over the interval from 2 to 4. All right. If we start at the left end point of this interval, x is 2, f of x is 2 cubed, which is 8. At the other end of the interval, at the right end of the interval, x is 4, and f of x is 4 cubed, which is equal to 64. Now, over this interval, x has changed from 2 to 4, or x has changed by 2. The change in x was 2. On the other hand, f of x has changed from 8 to 64, so f of x has changed by 64 minus 8, which is 56. The rate of change in y with respect to x is the change in y divided by the change in x, so that would be 56 divided by 2, or 28. Okay, we can look at this in the following image here. All right, notice that this is a graph of f of x is equal to x to the third, and at the left end of our interval at 2, all right, the function value was 8, so we're at the point 28 on the graph. At the right end of the interval, x was 4, the function value was 64, so the point on the graph at that end of the interval was 4, 64. All right, our secant line passes through those 2 points, shares the point 28 and the point 464 with the graph of x cubed. All right, we saw that the slope of this line was 28. What this means is that if we would move, if we'd start at some point, say 2, 8 on this line, if we would go over 1, we would have to go up 28 to get back on the line. Okay, so this point would be 3, and 8 plus 28, excuse me, is 36. Okay, so if we go over 1, we'd have to go up 28. The rise over the run would be 28. All right, and if we would go over 1 again, since we're on a line, we'd have to go up another 28. And that would bring us up to the 64. 36 plus 28 is 64. Now, all right, there's 2 things that I want you to realize here. All right, first of all, this was a secant line, and it was an average. It was an average rate of change, a secant line and an average rate of change. Because it was a secant line, the line met the graph at 2 points. An average rate of change is a rate of change using the values of the function, again, at 2 points. So this, when we see these words secant or average, we mean that they're determined by 2 points. And maybe I should add 2 distinct points. All right, the rates of change, this was also a rate of change in y with respect to x. Notice this was a change in y divided by a change in x. All right, this expression with respect to, if we look at this, the variable that comes before this expression in the phrase y with respect to x is a variable whose change is in the numerator. And the variable that comes after this expression, with respect to is the variable whose change is in the denominator. All right, let's look at more slopes of secant lines, okay? All right, so what I've done is, notice if we look here, we have already done some of these, one of these computations. If we looked at the interval starting at 2 and ending at 4, we saw that the change in y was 2. F changed from 8 to 64, so its change was 56. So the average rate of change in y with respect to x was 28. If, instead of using 4 as the right point, if we use 3 as the right point, well then x would have changed from 2 to 3, its change would have been 1. Y would have changed from 8 to 27, so its change would have been 19. The rate of change in y with respect to x would have been the change in y divided by the change in x would have been 19 divided by 1, or 19. If we do this on shorter intervals, all right, 2 to 2.5, we see that the average rate of change is 15.25. If we do that from 2 to 2.1, the average rate of change is 12.61. Then from 2 to just 2.01, 2 to 1/100th further to the right, the average rate of change is 0.601. All right, if we look at this, it seems that these values of the average rate of change, right, seem to be approaching a limiting value of 12. We'll see in the next video that that's the case, but we should look at a picture of what's happening here. All right, if we look at this function here, all right, this graph, all right, the graph of x to the third, all right, then on the interval from 2 to 4, we've already seen this tangent line, and we've seen, all right, that the change in y was 56, the change in x was 2, giving us a rate of change in y with respect to x, or a slope of 28. All right, if we move the 4 into the 3, okay, all right, now we're looking at the average rate of change just over this interval from 2 to 3, and the average change went down to 19. We see the slope is not, the line is not quite as steep. It only as we go over, when we only go up 19 instead of 28. All right, as we go from just 2 to 2.5 now, all right, the slope is 15.25, and 2 to 2.1. All right, the slope is 12.61, and the thing is, what we see is, remember we saw that slope value getting closer and closer to 12. All right, what we'll do is we'll see what happens to this limiting value of this slope in the next video.